In this video, we're going to talk about the central limit theorem for means. So here we are talking about a sampling distribution of sample means. So if we draw random samples of size n from a population, the distribution of the sample means, called the sampling distribution of the mean, approaches a normal distribution as n increases. And I don't know why there's a gap there. That's a little weird. We have this weird language here as n increases, and the question is, what does it mean for n to be large enough? And the answer is, as long as n is greater than or equal to 30, or the population is normally distributed, in which case I don't care about the size. A normal population will produce a normal sampling distribution. If I don't know the shape of the population, or if I know it's not normal, my sample size needs to be at least 30. And if that's true, the mean of the sample means will be equal to the mean of the population, and the standard deviation of the sample means will be equal to the standard deviation of the population divided by the square root of the sample size. So means are the same. Standard deviation gets smaller for a sampling distribution. And we actually saw that in the last video, we just didn't name it. If I go back up and I look at the spread of my raw data, my min is 60.7, my max is 70.5. That's a pretty big spread, even without calculating a standard deviation. But if I look at the sample means, my smallest sample mean in my sampling distribution is 64.48, and my largest is 67.4. By collecting samples and averaging them out, I'm kind of mitigating the extreme values and squishing everything inward towards the center. And what that does is that makes the spread much smaller. The bigger the sample size, the more pronounced that effect will be. Because for a sampling distribution, we have modified standard deviation, that's going to show up in our z-score formula. So when I'm calculating a z-score for a sampling distribution, my sample data is now a sample mean. The mean of my sampling distribution should be the mean of the population. And the standard deviation should be the standard deviation of the population divided by the square root of n. And I will caution you, if you're doing this manually, parentheses around the numerator, parentheses around the denominator when you plug it in a calculator. For normal calculations, use the modified standard deviation. So sigma should be the standard deviation of the population divided by the square root of n. And this is what you'll plug in the calculator. Alright, in the next video we're going to do some examples so you can see what a sampling distribution looks like in practice in terms of calculating probability. If you have any questions on what you just saw, feel free to send me an email. Otherwise, I will see you in the next video.